So today we'll demonstrate the integration of VehChain with a real car. So we did this experiment with Buick Encore car model. So here you see we have two ECUs that has VehChain installed into them, and one ECU, a light sensor is connected to it, and another ECU, a headlight bulb is connected with the ECU, and both ECUs are connected to the CAN bus of the car. See over there it goes and it connects to the CAN bus of the car. So these ECUs, so if I trigger here the sensor, then this data is transferred to the CAN bus, and this ECU receives this information and trigger this headlight bulb. So this communication is encrypted using VehChain. So turns on like this, and we have another headlight. This is connected to this Raspberry Pi, and this Raspberry Pi is also connected to the CAN bus of the car. Can you show the CAN bus? Through the OBD port over there. So this Raspberry Pi is listening the CAN messages of the status of the headlight switch. If the status of the headlight switch is turned on, then this will light the headlight. This Raspberry Pi will light the headlight. And if the status of the headlight switch broadcasted into the CAN bus is turned off, then it will turn off the headlight. So you can see, can you turn on the headlight switch? Yeah, so it's turned on. Can you turn off? So when he pressed the headlight button, then a CAN message was transmitted to the CAN bus conveying the on headlight status, and this Raspberry Pi read that message and it lights the headlight. So this communication is unencrypted communication. So today we'll compare, we'll try to do some attack and to compare how the attack goes on to this unencrypted communication and into this encrypted communication. So we have another Pi we connected to the CAN bus through the OBD port over there. This CAN bus, this Raspberry Pi will use as an attacker component into the network. So first we'll try to sniff, try to get the pattern of these communications, and then if we get any pattern, then we'll try to replicate that pattern in order to control these communications. First we try to control this headlight bulb. So the purpose of the attack is such that if we can replicate the CAN message similar to the headlight status on, so that this ECU turn on this headlight without turning on the real headlight switch. So now we try to sniff and see if we get any pattern of the message. So now can you so here this monitor shows the sniffing data of the ID 1020C040. So this ID actually transmitted the headlight switch status to the CAN bus. So you see, when he turns on the headlight switch, then the light is turned on here, and you see this is 0060150401. This the 8-byte data is transmitted. Can you turn off? So when it's turned off, the data is 0040040401. No light. Can you turn on? And when it's turned on, see the pattern is 006015. So these 2 bytes, 60 and 15, these 2 bytes actually representing the status. So when it's turned on, when the switch is turned on, then the pattern is 6015. Can you turn off? Yeah. Then the pattern is 4004. So now without pressing the button, we will send a CAN message using this pattern value so that we can turn on the headlight. Can we turn on or not? So that's the repay attack we'll do now. So from the Raspberry Pi, he is trying to scan send, and this you see the ID 1020C040, and this is the data 006015040001, 8-byte data we are repaying. So you see these 2 bytes 60 and 15. So it will turn on the headlight without. Yeah, you send and you see it is turned on. And similarly we can turn off the light to sending 4004, this one. So it's turned on. You will do again, turn on, turn off. So you see this unencrypted communication, we are able to hack using repay attack, such that this Raspberry Pi tricked to turn on the headlight without actually pressing the headlight switch. So we are successfully able to do the repay attack for this unencrypted communication. Now we'll try to sniff this communication happening here. So this communication is encrypted through VehChain. So we try to sniff those. He will go. So yeah, we are sniffing here. You see, this is the ID 126 for this communication. And you see now it's turned off. The light is turned off, and each and every communication, there is no pattern. It's changing, because our VehChain solution is encrypting each and every message with a new key, each and every time with a new key. So the encrypted message is changing, so there is no pattern you can identify. And if I turn on, if I turn on this message transmitting is also encrypted, and you see it's changing. So there is no pattern you can get, so that you do some repay attack. You cannot do any repay attack to control this communication. There is no way you can turn on this light through CAN send, because these communications are encrypted. We cannot break through this encrypted communication.